Well, hello. Welcome to Combining Functions Graphically. This is kind of part two, and what I want to do is specifically look at when we have one function divided by another function. And specifically those functions, the top function is second degree, or quadratic, or kind of an x squared kind of a function, and the bottom function is first degree, or linear, or just a regular x kind of function. We're going to show you some strategies here. If we're just looking at the graphs, how can we determine what this resulting divisional of the two functions, what's that going to look like? So let me just review a little bit here. So this will be a bit of a brief review. Okay, what if we had one that looked like this? So this goes back a couple of chapters where we were looking at these functions when they're stated algebraically. Okay, so I'm not looking at the graphs of these functions, I'm actually looking at them algebraically. Our strategy was if we could factor the top and factor the bottom, now the bottom doesn't need to be factored here, I might be able to simplify the function considerably. In fact, look what happens here. The x minus 5's, they cancel, and I'm left with a very simple looking function. Now when I look at this function, I know what its graph is going to look like. It's going to be a line. So it's a linear graph, and it has one difference between the line y equals x plus 2. Okay, our original graph came from this, and 5 was a bit of a troublesome spot. So there is going to be a point of discontinuity, or a hole, in this particular linear version of it, and that's the only thing that makes it different from this line graph here. So where is this hole? Well, it's when x is 5. If I plug a 5 in here for x, I've got 5 plus 2, or a y value of 7. Now there's no actual point there. It's a point of discontinuity. So let me show you what that graph would look like. I'm just going to clear the screen here, and I'll put a grid up. Okay, so let's see if I can do this successfully here and get my pen working again. Let's see here, I think it's, whoops. All right, I think we're good here. So I want to graph y equals x plus 2, but I want to make sure that at this location there's a hole. Okay, so I'm going to put in plus 2 is my y-intercept, okay, because of the plus 2. And then I've got the slope of this graph is 1, so it means going over 1 and up 1. So that basically shows me what my line's going to look like. It's going to carry on up like this. Okay, and I got to make sure at 1, 2, 3, 4, 5 and up 7, 1, 2, 3, 4, 5, 6, 7, I show that there's a hole. Okay, so let's see if I can connect this all together. All right, so there's my line. There's my graph. Okay, so what I want you to see, when you have a quadratic and you're dividing by a linear, one outcome is that the resulting graph of this division is a linear graph with a hole in it. Okay, now let's clear the screen and carry on to the other situation that could arise. And that is, what if we have something, say, like this? So, whoops, it's not very visible there. Let's see. Try this again. Okay, so my second example is, what if we have some function like this? X squared minus 2x minus 3, and that's all divided by x minus 2. Okay, so I carry on as before, and I factor the top, and the bottom's already factored, so that's pretty good. So factoring the top, I need to have a minus 3 and a plus 1. Nothing cancels this time, so there's really not much I can do except to notice that when x is 2, I'm going to have not a point of discontinuity, but a vertical asymptote. Okay. I'm also going to have to analyze that we have the distinct possibility of a slant asymptote happening here. And in order to figure out where a slant asymptote is, we have to divide the top by the bottom. So I'm going to do some synthetic division here and see what the equation of the slant asymptote is. So I'm going to go ahead and set that up. Okay, so we'll bring down the 1 and then multiply and add and multiply and add. Now we don't really care about the remainder. What we care about is this part of it. And so the slant asymptote is y equals 1x. So there's the slant asymptote, and we have a vertical asymptote. So let's clear the screen and we'll kind of get a picture going here of what this this graph would look like. So, okay, so got that pulled up, and let's see here. Make sure that this is working well. It seems to be. So we have at positive 2, we have a vertical. Just kind of dot that in. And we have this slant asymptote, which is a nice easy one. It's just y equals x. So we'll set that off in this direction and in this direction here. Something like that. Okay, in the original function, in the factored form, I had this as well. And what that tells me is that I have some easy to spot points called the zeros, or the x-intercepts, at 3, so 1, 2, 3, and at negative 1. And another point that might be worth getting is, what about the y-intercept? See where that is. So we put the y-intercept, x as 0, so we would have we'd have negative 3 times that by 1, and then divide that by negative 2. So that would be 3/2 or 1.5. Okay, so that's where this guy is. It's at 1.5. So now, what's my graph going to do? Well, what we have happening with these slant and vertical asymptotes is this side of the graph must be doing something kind of like this, heading down towards there. And this side here must be heading up. I know it can't head back down. Whoops. I'll just fill this in here. Thicken it up. There we go. That makes it look better. Okay, why can't it bend back down? Because there's no x-intercepts in this area here. So I know it had to go up. Similarly, this is my only x-intercept here. So I think my graph's going to do something like this and like this. Okay, so those are the two situations. Essentially, what can happen is when you have a quadratic, so you have some kind of an x squared or second degree parabola divided by a linear, there are two things that can happen. Either the result is that you have a line with a hole, or you have a vertical and a slant asymptote, and you have kind of two curvy graphs, two curvy zones. Okay, so that's in summary what we see happening here. And when I come back, we're going to show you, well, what if you don't have the algebraic functions to work with? What are you supposed to do? How do you know which of these two graphs you're looking at? So we're going to stop there. We don't want to keep going here. Come back with more.